Welcome everyone to day 57 of our low-level design course. Today we will be diving into two of the most critical aspects of system design, documentation and UML diagrams. These two elements are essential for transferring your design from an abstract idea into something that is both understandable and shareable. They ensure your design isn't just effective but also comprehensible by others. By the end of today's session, you will be equipped with the knowledge to turn your design into professional, polished assets that are ready to be presented and implemented. Let's take a moment to review the key objectives for today. First, we will explore why documentation is so important in low-level design. You might be thinking, isn't the design enough? Well, while the design is important, without solid documentation, it's hard to ensure others will understand or maintain over time. Next, we will learn how to create UML diagrams that are professional, clear, and easy to understand. These diagrams will serve as blueprints for your system, allowing developers, stakeholders, and even yourself to visualize how everything fits together. By the end of today's session, you should be able to create submission quality documentation and UML diagrams that will serve as the foundation for your final project presentations. So why does documentation matter? At its core, documentation acts as a bridge between your design and the actual implementation of that design. It's not just for your benefit but also for others who might be working on your system now or in the future. Good documentation helps clarify your ideas, making sure everyone is on the same page. It allows stakeholders, developers, and even non-technical users to quickly grasp the system's functionality, which can significantly reduce errors and misunderstandings during development. Moreover, documentation ensures long-term maintainability. As systems evolve, your design will need to be updated, scaled, or integrated with other systems. A well-documented system is much easier to modify and extend as it provides a clear roadmap of how everything fits together. When you are creating your documentation, it should be comprehensive enough to answer three key questions. What are you building? Describe the system you are developing, its purpose, and the problem it solves. Why are you building it this way? Provide the reasoning behind your design choices. Why did you choose a particular architecture, technology, or approach? How will it work internally? Detail the inner workings of your system, the relationships between components, classes, and processes. This is where diagrams and flowcharts can be particularly helpful. To ensure that your design is thorough and understandable, you need to prepare several key documents as part of your final submission. Technical design document. This is the core of your documentation and should explain the overall design and architecture of your system. Module-wise documentation. Break down the system into smaller, manageable pieces and explain how each module works. UML diagrams. These visual tools provide a graphical representation of your system. You will create class diagrams, sequence diagrams, activity diagrams, and possibly component diagrams. This will help convey the structure and interactions within your system at a glance. Now let's dive deeper into the technical design document itself. A well-organized document includes the following sections: introduction and background. Provide context for the system you are designing. Why does this system matter? What problems does it solve? Requirements. This section should list both functional and non-functional requirements. Functional requirements describe what the system must do, while non-functional requirements address performance, security, and other qualities. High-level and low-level design. The high-level design gives an overview of the system, while the low-level design goes into the specifics like the structure of classes, methods, and interactions. Data models. It includes any data models or database schema if applicable. Error handling. Describe the strategies you will use to handle errors and exceptions. Testing strategy. Explain your approach to testing the system, including unit tests, integration tests, and system tests. Scalability plans. How will you how will your system handle growth in traffic, users, or data? Future work and limitations. It's always good to acknowledge where your design may fall short or areas that could be improved in future iterations. Let's now do a quick refresher on UML diagrams, which will play a significant role in your documentation. Class diagrams. These diagrams show the static structure of your system, displaying classes, their attributes, methods, and relationships. Sequence diagrams. These diagrams represent how objects interact with each other over time, showing the order of method calls. Activity diagrams. These diagrams capture workflows, such as the steps a user or a system follows to complete a task. Component diagrams. These diagrams give an overview of the architecture of your system, showing how different components interact with each other. Now it's time to get hands-on. For today's session, you will work on your capstone project and create the following diagrams. A class diagram that illustrates the structure of your systems, classes, and their relationships. Two sequence diagrams to show how objects interact in key use cases. An activity diagram that maps out the workflow for a particular task or process. A component diagram if you want to provide a more detailed architectural overview. Remember, the goal is to create clean, understandable diagrams focusing only on key elements. Don't overcomplicate things, keep it simple and clear. When it comes to diagramming, there are several tools that can help you create professional quality diagrams. Draw.io. This is a free web-based tool that's incredibly flexible and widely used for creating UML diagrams. Lucidchart, another great tool that offers advanced features and an intuitive interface for building diagrams. Visual Paradigm. If you need a more robust enterprise-grade tool, Visual Paradigm offers comprehensive UML capabilities. Microsoft Visio, a familiar tool in corporate environment, Visio is often used for more formal diagramming. We have provided several helpful templates and resources for you today. Design document templates. You will find a structured template to help you organize your technical design documents. UML diagram templates. These are pre-made templates for class, sequence, and activity diagrams, which you can customize for your project. You can also review example submissions from past students to get an idea of what works well and what doesn't. Finally, make sure to review the grading rubric to ensure you are meeting all the necessary requirements. When it comes to preparing final documentation, follow these best practices. Your document should have a logical flow, starting with the introduction, then moving on to the design and testing sections, and ending with a conclusion. Break your documentation into modular sections to make it easy to navigate. Use consistent formatting and naming conventions throughout your documentation to make it look professional. Always include a table of contents so readers can easily find specific sections. And don't forget the importance of proofreading. A document full of errors is not only hard to read but also reflects poorly on your professionalism. For today's assignment, your goal is to create the documentation and UML diagrams for your capstone project. Specifically, you should draft the technical design document based on the template we provided. Draw the required UML diagrams, class, sequence, activity, and component if applicable. Submit your work for review tomorrow during presentation day. Additionally, participate in a peer review by exchanging your work with a fellow student and providing constructive feedback on each other's work. By the end of today's session, you will have produced professional grade documentation and UML diagrams. You will be ready to present your capstone project with confidence, knowing that your design is clearly communicated and well documented. These skills are not just crucial for this course, but for any future system design projects you may undertake. And that brings us to end of day 57. Thank you all for your hard work today. Remember, as Steve Jobs famously said, design is not just what it looks like and feels like, design is how it works. As you work on your final projects, keep this in mind. It's not just about how your system looks on paper, it's about how efficiently it works and how well it can be maintained. We are excited to see your designs come to life and can't wait to see your final presentations tomorrow. Thank you for your attention.